In this lesson, I will be going over how to find a linear regression equation using a calculator based on a specific scatter plot of data. A scatter plot is a graph of data from two quantitative variables. So this will be bivariate data. You're going to have two different variables. And you're going to be graphing them on the same coordinate plane to basically determine if there's an equation that can model the data to see if the two variables are related in any way, and also how closely related they might be. So you're just trying to see what type of relationship the two variables might have. They may have no relationship. It just depends on your scatter plot. It may be linear, a linear relationship. It may be a nonlinear relationship. So you just kind of have to do a scatter plot to then determine whether a linear regression equation makes sense for that specific data set. We can fit a line through a scatter plot to represent an equation of fit to help us make predictions, reasonable predictions, about the dependent variable within a specific range. So basically, you can't go too far outside, make predictions too far outside the scope of your data because certain things might change in the future. One of the things that we've done before in the past was gas prices many, many years ago. Gas prices were rising quickly. Actually, right now they kind of are too, so we could probably do it. But depending on the time, sometimes gas prices are rising very quickly. And basically, we were just curious to see if we could make a prediction about future gas prices within the scope of a year. And so we made a regression equation and we made our prediction, and then we waited a certain amount of time and we wanted to see if it was true or not. And surprisingly, we were like spot on. We made a correct prediction about the gas prices. So that's kind of just an example of maybe where you can use that. If the data follows a linear pattern, then you can write a linear regression equation for your data and make reasonable predictions. So I have an example here. If you have the notes, I want you to pause it and draw a line through the data of where you think it would best fit. Now, notice that the dots on this scatter plot, I did this scatter plot in Fathom, but you can do it in your calculator too, which I'll show you. You can see it's got this general linear trend. All the dots, except for one, we have one that's kind of up out of the way, but all the dots are following this trend. And so one of the things that you can do to see if it's actually linear is circle the majority of the data. And if they're all kind of following this general trend, downward trend, then we can reasonably write a regression equation for it. So if we were all to just draw a line of fit, all of our lines might look a little different, relatively the same general direction. They're all going to be going down at a specific steepness. Yours might look a little bit different than mine, and that's okay. So to prevent all of us getting different lines for the same data set, there are ways that you can, there is a formula you can use so that we all get the same equation of fit. In this specific lesson, I don't use the formula. I feel like it's a bit tedious and there's lots of room for mistakes. So I like to use software. I like to use calculators or Fathom or other statistical software because it's more accurate. And this is called the least squares line. And basically you're trying to find the line with the least amount of error. Error is referring to the space between these dots and the line. And you want to find the line that has the least amount of error so that it accurately represents your data, the trend of your data. And This process, I have this in the notes if you have the notes, is how you use a TI84 or 83 to find this line of fit. You can use this you can do it in Fathom also pretty easily. If you have Fathom, just email me and I can step you through that. But for the most part, my students have the TI84. So that's the one I used for this. You can also do this in the TI Inspire really easily. There's lots of videos on that. If you need help with it specifically, let me know and I can help you. So before you even start, you have to go into diagnostics, the catalog, and turn your diagnostics on. And I want to show you how to do that. This app is the Graph in Calc. It's just an app. It's free for now, at least. You're going to go to second 0, and that pulls up your catalog. You're going to scroll down to the D's, and you'll see diagnostic on is an option. I'm going to turn it on. Hit enter, and you can see done. That means it's done. And then what you're going to do is you're going to go into stat, edit, and you're going to input your data. I'm going to clear this. I went up to L1, hit clear, and then went down. I will say if you hit delete, it will delete the entire column. It'll delete L1 also, so just be careful with that. If you did that, let me know and I can help you. You're going to input your data, and then actually, we'll just do an example. I'll step you through it. Oh, not yet. Input your data. I lied. Input your data, and then you're going to get out of there, second mode to get out of there, and then go to stat calc, hit linear regression, and you're going to have your equation. Super easy, super quick, super simple. The formula is not fast at all. And if you make rounding errors, then there's error, just lots of error. So I really don't like to do the formula. Before you can even write your linear regression equation, you want to look at your scatter plot. So you want to draw a scatter plot of your data points. And then if it does not follow a linear trend, then you should not write a linear equation for it. There are nonlinear equations for it, but that is far beyond the scope of this class. So basically, you're going to be having linear regression equations. Those are your only options. That's your only option for this class. The data must have a general trend of a linear pattern. If the scatter plot shows a nonlinear relationship between the two variables, then finding a linear regression line does not make sense. If you do decide to go ahead and run a linear regression simulation or whatever on it, then just proceed with caution about making predictions. Just note that maybe your data is not accurately explained by the equation. You probably shouldn't do it, but if you do, just be cautious about drawing conclusions. So down below, I have 3 examples of scatter plots, and you're deciding which one would be appropriate to find a linear regression equation for. So pause it and circle the one that you think is best represented by a linear equation. Hopefully, you chose this one. This one's nonlinear, and this one's nonlinear. So this one is very linear. It's would be really nicely explained by a linear regression equation. In future videos, we will decide, we will calculate how closely a scatter plot is represented by whatever linear equation we find, but that's later. So I have an example here. We have 8 students' study time in hours over the course of 2 weeks, and the test score that they got, and we're trying to see if there is an association between these 2 variables. And so X is representing the hours and Y is representing the score, and we're just wanting to write an equation. Before we write the regression equation, let's look at the scatter plot. I thought I had that on here. I don't. Let's look at the scatter plot of this data. So go to your calculator And we already turned the diagnostics on. So now let's input the data into L1 and L2. Let's let L1 be X and L2 be Y. So go ahead and do that. Once you've input your data, you want to check and make sure that you have inputted it correctly. And so you want to make sure that 11 is lined up with 93, 1680, 1385, and so on. So I double checked mine. Mine should be good to go. They all match up. There's 8 students, so that should be all correct. And then you're going to go to second mode. And before we write our equation, we're wanting to check our scatter plot. So you're going to go to second stat plot. Mine's going to be a little bit different than yours, but you're still going to choose the same graph. On mine, I'm going to click this little graph. I'm going to scroll up to the scatter plot. It's the one with the dots. And then mine for X list is L1, for Y list is L2, so that's right. And then in yours, you can do, if you have a handheld calculator, you can do zoom 9. And that zooms in on the statistical or the stat plot that you're looking for. I'm going to look at my y equals and make sure that it is cleared. It is cleared. I don't want anything else on the graph. I'm going to hit graph in mine. Let's see, I'm going to zoom way out because they're in the 90s. There we go. If you did zoom 9, it'll zoom in on the data specifically. If you didn't, you might have to change your window to adjust to these values in this problem. So our Y values are way up in the 80s and 90s, and that's why I had to zoom way out. And our X values are down in the teens. So I had to kind of go over to find that. But you can see the red dots. You can see the pattern there does follow a linear trend. So this does make sense to proceed with the problem. So even though my first question is what is the regression equation, before you get into that, you should look into the scatter plot. It is linear, so now I'm going to proceed. I'm actually going to, nope, I'm going to proceed. So I did second mode to get out of my graph, or you can do done depending on what you're using. And then I'm going to go to stat, calc, and there's 2 options for linear regression. Number 5 is AX plus B. That looks good to me. Number 9 is A plus BX. So the A's and the B's are switched. You're going to get the same equation either way. You just need to pay attention to how they list the equation and what A and B is. I'm just going to choose number 5. My X list is L1, so I'm going to do second 1. My Y list is L2. That should be enough information, I believe. Yeah. And then I've got all this information on the screen. So the top line says Y equals AX plus B. And then it says that my A value is negative 0.853 repeated, and my B value is 95.55. So I'm going to take these values and I'm going to substitute them in to my equation. So Y equals A X plus B. And that's the regression equation. Isn't that so beautiful, so fast, so clean? I love it. And then it says, sketch the regression equation in a graph. So we're going to go back to our calculator. I'm going to go to Y equals, and I'm going to type in this equation. Negative, you're going to use the small negative down at the bottom, 0.853. X is up by mode, plus 95.55. Then when I go to, you can either hit graph or zoom 9. Uh-oh. Oh. I got a problem. Look here, my line does not match my scatter plot. Hold on, I gotta troubleshoot. Okay, see what happened. I went back to my stat plot. I should have noticed this at first because I've done this problem before, but if you look at my Y list, it says L1. I need to change that to L2. So hopefully you weren't freaking out when you saw that your scatter plot was different than mine. I'm very sorry about that. I like to leave my mistakes in the videos because hopefully you learn from them and see that we just all make mistakes. So when you do make a mistake, when you see something that looks off, like I did in the graph, I'm hoping that that alerts you to go back and look at the things that you've already done. So that's why I like to leave the mistakes in the videos, because hopefully it helps you to see how I walk through those issues when there's something wrong. So I'm sorry if I caused any confusion. Hopefully it helps you in the future to see that. Sorry. Now I'm going to go to graph. Now that looks a lot more accurate. Okay, this is making a lot more sense. You can see the red dots are going in a downward trend. They're not perfectly linear, but they are following that linear trend. And then my regression equation that I found does match the data now. So that was an indicator that something was off, went back and checked it. That's more accurate. And you could sketch this by hand and just kind of get close. Or if you're using a device like I am, you can screenshot that. Or if you're on a computer, there's a snippet, screenshot, snippet. It's a snippet, like widget or app or something. And then I'm going to go add a photo to this and life hack. I don't have to draw it. You can draw it if you want to, but there's that. It's a little hard to see on here. There we go. That's better. And if you're doing a research paper or you're submitting a document where you need this graph, that's a really good method to do that. You can also do this in Google Sheets. And I do have a how-to document on how to do that. I'm not going to walk through it in this video for the sake of time, and probably because most of you have a calculator. So if you have a handheld calculator, you can even like take a picture of it with your phone and then send the picture to yourself. That would be okay too. Not as professional, not as nice and neat, but equally as effective. So that's how I would do that. And then we're describing the relationship between the two variables. So based on the scatter plot, we can see that it's going in a downward trend, which means that I'm going to draw that downward trend. As X increases, Y decreases. So you might be thinking, what is she talking about? X represents hours. So as students studied more, their grades decreased, which is a little bit surprising if you think about it. I would think that a student who studied more would make a higher grade. But this is, first of all, this is a really small sample. It's only 8 students. And it's probably specific to this particular class. And it might be explained by maybe the students who studied more were the students who struggled more in the class. Maybe the students who studied less had more natural, maybe were more mathematically inclined. It just depends on the student specifically. So we don't get a full picture just based on the linear equation. We have to kind of look at each student in this particular case. It would be a lot more helpful if we had a larger sample. We would get more accurate information, but maybe you're just one teacher studying one class and you know your students and you're trying to figure out what's happening, maybe. The slope of this equation if you remember, our equation was negative 0.853x plus 95.55. The slope was this negative number. And what that means is that scores drop 0.853 per hour of study on average. That negative means that they're dropping. And let's see, I don't think I have it on here. The y-intercept represents the score at 0 hours. So a student who studied 0 hours could make a 95.55, which is crazy. I think that's crazy. As a studier, I think that's crazy. I study a lot. Okay. Use the equation to predict the score of a student who studies for 5 hours. 5 hours represents X. So using this equation, I want you to pause it and try it and make your prediction. Since hours represents X, then 5 goes in place for X, and then you can just type that into your calculator. Negative 0.853 times 5 plus 95.55 is 91.285. So a student who studies for 5 hours is expected to make about a 91 on the test. Now the next one, use the equation to find the number of hours a student would need to study to make a 95 on the test. So in this case, now we're given the score and we're looking for the hours. So I want you to pause it and try it. Hopefully you have set it up like this, where the y value is 95, and then we're going to have to do a little bit of solving. We're going to have to subtract the y-intercept to figure out how far away it is. Make that a 0 instead. There we go. And then we have negative 0.55 equals negative 0.853x. Your last step is going to be to divide by that coefficient. And then you can type that part in your calculator. That divides to 1. And you should get about 0.64 or 0.645 is fine. You'll notice I did the squiggly equals because I've rounded. So this is 0.64 hours. And we could multiply that by 60 to figure out how many minutes that is, which is going to be about 38.4 minutes, depending on what they ask you for. You have to pay attention to what they ask you for. So if you want to score a 95 on the test, then you need to study for a little over half an hour. I think that's all I have for this lesson. Yes, that's all I have for this lesson. If you have any questions, please let me know. I'd be happy to help. And that's all.